In this video, we're going to continue with our solving. We're going to focus more on logarithmic equations today. So we already looked at this property that if exponential bases match, then x is equal to y. I also have if a is equal to b, then log of a is equal to log of b. Now, there are some restrictions on this. So a and b must be positive. We cannot take the log of 0 or a negative number. So that's what I have over here. Solutions to log equations must be within our defined domain. So we cannot take the logs of negative numbers or 0. Okay? And that comes from we cannot take anything raised to a power and result in a negative number. Okay, so or 0. So that's where that comes from, because remember, logs are the inverse of exponentials. So when we're going to undo logs, we're going to use an exponential that has the same base when we are solving. Okay, so in this one, I have log base 2 of x equals 4. So I want to get rid of log base 2. So I'm going to apply an exponential of 2, because 2 raised to the log base 2, those are inverses, and they will cancel. So x equals 2 to the 4th. And 2 to the 4th is 16. Okay, natural log is base e, so its inverse is e. So we're raising both sides of the equation with a base of e. So I have x is equal to e to the 5th. This one is pretty large. You can type this in, I guess, but if I wanted to approximate, 148.41. Oh, 148. Okay. So exact answer, approximation. Okay, here, this is not common log, right? With no base, I'm going to assume it's log base 10. So I'm going to raise both sides. So I have x squared is equal to 10 to the 4th. So x squared is equal to 10,000. A 1 with 4 zeros, so I'm going to square root. So x is equal to plus or minus square root of 10,000. So when we take the square root here and I get 100, so this is where I have to check my answers. So anytime, especially I get a negative, remember we cannot take the log of a negative number or 0. So if I were to put 100 back in here, 100 squared is 10,000. Negative 100 squared is 10,000. So I'm still taking the log of a positive 10,000. So both of these here are okay. So sometimes my negative numbers will be okay if there's something like this happening where it's being squared first. So it's going to be positive before I take the log. So here I had two solutions, positive 100 and negative 100. Just like with exponential equations, before I do anything, I have to get the log part by itself. So I'm going to add 3 to both sides. And I'm going to divide by 2. So I have natural log of x minus 3 is equal to 5 halves. Now I'm going to undo the natural log by applying e. So that will cancel. So I have x minus 3 equals e to the 5 halves. I'm going to write that as 2.5. Add 3. So exact answer, approximation. So we have e raised to the 2.5 and then plus 3, about 15.18. Okay, here, log base x. So to solve for x, it's easiest to put this in exponential form. But you can think of if I wanted to undo the log, right? It has a base of x. So if I apply x to both sides, I have x squared equals 25. Okay, square root. So I get x is equal to plus or minus 5. So let's check this. So remember, one of my rules is that I cannot have a negative base either for a, right? So if a equals b, right, log bases, I guess I don't have that there. But one of our, I guess I'll just stipulate that here. Our bases of our logs must be positive. So here it cannot be negative 5. So I'm just going to say x equals 5 is the only solution that works for this equation. My base must be positive, and I cannot take the log of a negative or 0. Okay. All right. Here is another rule, you guys, just like the exponential equations. If my log bases match, then their arguments are equal to each other. Okay. So I have these two expressions where my log bases are equal, so that means their arguments are equal. So I can jump right to that. You can also think of if I applied 2 to both sides as an exponential, it would cancel those logs right away. So we'd be left with x plus 7 equals 3x plus 4. So I've got 2x equals 3. So x equals 3 halves. All right, here I have x squared, right? My bases match, so I'm going to say x squared is equal to x plus 12. This is a quadratic, so I'm going to set it equal to 0. And this one factors nicely. Numbers that multiply to be negative 12, that add up to be negative 1, negative 4, and 3. So x equals positive 4 or negative 3. Negative 3 is okay here because it's squared. Negative 3 plus 12 is okay there because negative 3 plus 12 is 9, so we're still okay. I don't end up taking this log of a negative when it's negative 3, so we're good. So both of those solutions work. Now sometimes when you are solving a log equation, if you have multiple logs on a side, you want to condense them first. So when I add 2 logs with the same base, I can rewrite it as multiplication. So this is log base 2 of x times x minus 6. Okay, so now I can apply my exponential of base 2 to both sides. So here I have x squared minus 6x, if I distribute that, equals 2 to the 4th, 16. Again, I'm going to set that equal to 0. So numbers that multiply to be 16, that add up to be negative 6, negative 8, and 2. So x equals 8 or negative 2. So let's check those. So 8's fine, right? 8 minus 6 is okay. But negative 2, when I plug it in here, I would get log of negative 2 minus 6. So log of negative 8 is undefined, or we say does not exist. So this guy is extraneous, is what we call that, an extraneous solution. So x equals 8 is the only solution that works for this equation. Okay, that's it for this video.